Here's the question that I asked at the end of the previous part of this lecture. So we can figure out which way the field points at P fairly easily because there's only one charge in this whole region. Remember that the field is defined in terms of forces on probe charges. So think about what would happen if we put, say, a positive probe charge at point P. It would be attracted to that negative charge Q. In other words, there would be a force on it towards the charge Q. And the definition of the E field is that it's just that force divided by the charge on the probe. Since that's a positive charge, dividing the one vector by the positive number gives a vector in the same direction, and so the E field points down. Note that there's nothing special about this point P. If we repeated this process for other points near this charge Q, we would always find that the forces on our positive probe charges would be towards the charge Q, and so the field must point in towards this negative charge everywhere. And that's going to be true for any negative charge. Students often get quite confused by the meaning of the electric field. First and foremost, remember that it's a property of the point in space, and it's caused by some charges elsewhere that you would call source charges. They are the source of this electric field. And remember that we thought about determining this electric field by thinking about putting a positive charge here. And we know that if we put a positive charge here, it feels an electric force in the direction of the electric field. But realize that this in no way depends on what charge we put there. The field is independent of what charge we use to calculate it. So for example, if you put a charge there that's twice as big, well, the electric forces on it, due to all those source charges elsewhere, will increase. If you put twice the charge there, it'll have twice the size of electric force. But since you then divide out the charge to get the field, you would find the same field. Similarly, if you put a negative charge here, think about what would happen. Remember that this field might be, we don't know, it might be produced by a bunch of positive charge over here, or it might be produced by a bunch of negative charge over here. But either way, the force on this negative probe charge is going to be back this way, opposite the direction of the field. And you might think then that you would measure a different field if you use a negative probe charge. But think of that. You're now taking this force vector, dividing it by a negative Q probe, and so that means that the electric field will point in the opposite direction to the force, back the way we had it before. So the electric field is independent of what probe charge we use to measure it. It's being caused by source charges elsewhere, and if we don't change them, then the field here remains the same. Let's check your understanding, and I'll warn you, what I'm asking you here is something that most people find counterintuitive when they first encounter it. So, let's say we have some location that we've called P, and we measure the electric field at P using a positive probe charge, and we find that the E field points to the right. Now, we remove that positive probe charge that we were using, and we remeasure the field, but this time we use a negative probe charge to do it. So, measuring with this new negative probe charge, which way do we find that the E field points at P?